part B, we're going to do the same thing. We're substituting again. So we have x is -1, y is 3, and then times a quantity of 7 times z, which is 2, all over x, which is -1, it's being squared, times y, which is 3. Now, whenever I have this division bar, it's very important for you to remember that this division doesn't follow order of operations until everything on the top is simplified and everything on the bottom is simplified. So I'm going to simplify on the top first, and on top I'm going to multiply inside these parentheses first. So I have -1 times 3, and then inside those parentheses is 7 times 2, which is 14, all over. -1 squared is a +1 times 3. I can simplify at the same time on the top and on the bottom because nothing is happening between them until that division step. So then I have -1 times 3, which is going to be -3 times 14, over 1 times 3 is 3. -3 times 14, okay, negative times a positive is a negative, and then 3 times 14 is going to give me 42, and then 3 is on the bottom. When I divide this, I get negative, because a negative divided by a positive is a negative 14. You could have also seen that 3's will cancel here, same thing. Simplify each expression, then evaluate. Okay, it wants us to simplify first. So that means that we need to get this in the simplest terms possible. So what it's asking us here is that this negative x can be distributed to everything on the inside. Okay, so I have -x times y is -xy. Negative times a negative will give me a positive. And then I have 3 times that x, which is 3x plus y. Okay, I can't simplify this any farther because I don't have any like terms, so now is the point that I can go ahead and substitute. I have negative, instead of x, I'm going to put 0.75 times y, which is -2.5, plus 3, instead of x, I'm going to put 0.75, plus y is a -2.5. So I have a -0.75 times -2.5. A negative times a negative, I know, gives me a positive. 0.75 times 2.5 will give me a 1.875, plus, these are both positives, so 3 times 0.75 will give me a 2.25. Plus that -2.5. Now all I have is addition, which I'm going to do from left to right. You can also think of it as addition and subtraction because these two signs we know is going to give us a negative, but still it's just addition and subtraction, which we work from left to right. So when I add these two, that gives us 4.125. And then I'm going to subtract that 2.5 because of our sign change there. And that's going to give us 1.625 as our final answer. On B, go ahead and pause. I want you to simplify before you evaluate. That means simplify before you substitute. Alright, so part B, we're going to take x to everything inside. So x times x gives me x squared, plus 2y times x is going to give me 2xy, minus x. Same situation here. I don't have any like terms because for them to be like terms I must have the exact same variable with the exact same exponent, and I do not. So I'm going to go ahead and substitute at this point. Okay, looks like I have a little exclamation point here, I apologize. X is 1/3, so I'm going to substitute 1/3 in parentheses. It's being squared, plus 2, instead of x, again I have 1/3, times y, which is 1/2, which I put in parentheses as well, minus x, which is 1/3. Okay, that is a parenthesis, it just looks poor. Okay, so order of operations, I'm going to do my exponents here. 1/3 times 1/3 gives me 1/9. Plus, I can go ahead and, because of this addition and subtraction, those separate terms, so I can go ahead and simplify within each term. So 2 times 1/3 is 2, and 2/3, excuse me, times 1/2 minus 1/3. Okay, so that took care of this part, and this is right here. 1/9 still doesn't change. Plus, when I'm multiplying these two, this is going to cancel because this is in the numerator, this is in the denominator. I can cancel over that multiplication. So I have 1/3 minus 1/3. So now I have to follow my order of operations, which is addition and subtraction from left to right. I know that 1/3 is the same as, I'm going to cancel this out and call it 3/9 instead. I have to have a common denominator. So 1/9 plus 3/9 is 4/9 minus 1/3, which we just said was 3/9, which gives me 1/9 as my final answer. This is just a fancy way of saying evaluate the expression using these variables. So it says if b is -3 and z is 6, what is zb to the third? So I'm going to just substitute like I have been. Instead of z, I'm going to put 6. Instead of b, I'm going to put -3, and that's to the third power. Whoops, don't forget those parentheses, it'll change your answer. Now I need to follow order of operations. -3 to the third power, it's very important if you're using your calculator that you punch it in exactly the way you see it. If you don't, it will be wrong. So it's parenthesis, -3, not minus, negative, use the negative symbol. Close the parenthesis and then caret 3 to get that exponent of 3. And that's -3 times -3, which is +9. +9 times -3 gives us a -27. Times that 6 gives us -162. Final answer. Okay. B, go ahead and pause and try to work it on your own. B wants us to evaluate if m is equal to 5. So these bars, even though they look really poor, those are actually absolute value bars. Okay, it's just the way the program types them out. So I have the absolute value of -m, which is 5, and that is to the third power. So I have, this is just going to give me -5. So I have the absolute value of -5 to the third power. Well, I can punch that into my calculator as parenthesis -5 caret 3. That gets me the absolute value of -125. And the absolute value is the distance from 0. Okay, remember it is not the opposite, it is the distance from 0. And -125 is 125 units from 0. That's our final answer. Last example here. Oh, I can't scroll on this. A savings account increases as interest accumulates according to the formula, and a p sub y equals 1.04 times the quantity of p sub y minus 1, where p sub y is the principal balance at the end of y years, and p minus 1 is the principal balance after y minus 1 years. After 6 years, there is a principal balance of this much money, which is $1,450. How much is the principal balance after 8 years? So what you need to do is, we know what it is after 6 years. Okay, we know that p sub 6 equals $1,450. Okay, but in order for us to find what it is after 8 years, we also have to find what it is after 7 years. So to do that, we're going to have to use our formula here. Okay, so what we know is that p sub 7 would have equaled 1.04 times the quantity of p sub 7 minus 1. Well, p sub 7 minus 1 is the same as saying p sub 6, which we already know. So instead of p sub 6, we're going to plug in, or instead of p sub 7 minus 1, we're going to plug in p sub 6, excuse me. So I have 1.04 times the quantity of $1,450. So whenever I do that, I have 1.04 times 1450, and that gives me that p sub 7 is equal to $1,508. And what I'm going to do is I'm going to take this and I'm going to use it to find p sub 8, because that's what I really want. I want to know after 8 years. So I know that the formula for p sub 8 would be equal to 1.04 times the quantity of p sub 8 minus 1. Well, p sub 8 minus 1 is the same as saying p sub 7, which I now know. So I'm going to take this value and I'm going to plug it in here. So I have p sub 8 equals 1.04, and instead of p sub 7, I'm using this value, which is 1508. And when I multiply that times the 1.04, that is going to give me p sub 8, or after 8 years, the principal balance will be $1,568.32. Pretend that looks like a 3.32 cents. Final answer.